Hello everyone, my name is Kwai Wong. Today I'm going to talk about the Anchorage paper that features satisfaction evaluation for customer service videos. So customer services are characterized by their goal orientation. For example, if you bought something online, then you bring questions to the customer services. You need to achieve some tasks. So between you and the customer service agents, there are communication dynamics, which is rarely researched in the visualization community before, except for text analysis maybe. So, but in customer services, measuring the satisfaction is of great value to improve their quality and business outcome. They would usually use something like you give like or dislike after the service, you have questionnaires, or they measure by complaints. However, this kind of indirect measurements will have some flaws. For example, we found that only perhaps 10% of people would give the direct labels to the service, which means that the data is scarce. Second, if you conduct questionnaire sections or even more workshops-based method, it will be very costly to acquire this data, so the data size will be limited. And also, after the services, people will recall differently, so they may have cognitive biases. And also for complaints, it will create uneven samples such that you don't know where you do good, or people would like to complain more than compliments. So return to passive evaluation methods. We take surveillance video as our main method, because we think that, well, compared to other passive methods such as wearing glasses or even wearing MRIs, then this will be more low-key and accessible data sources. So in visualization community, we have done a lot of video-based analysis. Not even us. The AI community also use facial expressions or multimodal features to train up satisfaction scores. However, these methods would generally focuses on having the correct emotions being classified rather than to see whether the people are satisfied. They lack a reasoning and cost analysis. And other works would contain a single channel communication, which usually have one information deliverer and others are recipients. They do not really give you feedbacks and do not have the dynamics. Therefore, previous works in the visualization community would usually only have modalities that are related to their specific domains and seldom consider a structure to guide the user attention, which is required in satisfaction analysis. And also one final note on the limitation that other works might not be applied to our domain is that facial expression will contain various emotions and do not equate satisfaction. Take a look at this internet meme that is online. Usually, if we see someone has a frown and also a downward smiles, then we'll consider it is a negative emotion. However, in this internet meme, it actually means not bad. And some people would also use a good facial expression to deliver bad news, and this is considered polite. So if we are simply using facial expressions or any other emotion classification models only, we will have poor results in satisfaction evaluation. So we approach the problem with three main solutions. I will go through them one by one. So first, we make an improvised data set to characterize the domain, and we have multimodal data analysis and fusion for computational support. And finally, we have a set of new design of visualization to facilitate facial analytics. So we need to review what is exactly satisfaction. So take a look at this example. Although we can have the same performance output, if we have a different expectation, it would be having a different reaction to this outcome. it is simply because that the customer have a different expectation over the product or the service. So an under fulfillment will give you a negative satisfaction, and an over fulfillment will give you a first satisfied experience. So we can see that the emotions is only the outcome of the favorable result, but not the root cause. So we utilizes some customer service workflow to provide the temporal data records for analysis. For example, in customer services, the agents will have their own guidelines to how to serve your clients. And so based on these guidelines, each procedure will be different due to the different real-world scenarios or different issues. And finally, the service record will contain some log-based records for our analysis. So we make advantage of this, and we collaborated with digitalization service providers to collect real videos for tax-paying tax services. So it will help us to obtain the videos and also machine logs. However, due to the COVID-19, we will have a hard time collecting enough video samples that can fulfill our requirements. So we have examined, interviewed domain experts to summarize 4 common patterns for satisfaction. And one is for satisfaction and neutral, and 2 cases of unsatisfied services with a different result, a different reason. One is because that the agents might be incompetent, denoted by DA, and one is denoted. One is that the procedure is unreasonably long or repetitive, such that it will be annoying to conduct the service, denoted by DP, the disappointed agent, disappointed procedure. So we asked the service agents to help us to make these cases, and then we analyze these videos with AI models. So we have the visual channels, the acoustics channels to give us 2 different emotion scores for each time frame of the service video, and also we have the service records that we have done anomaly detection to help us to prioritize the patterns that we need to see. So in short, one anomaly that we want to find is that if compared to the normal sequence, it will have unreasonably short or long or repetitive, then this will raise awareness of our agents who later review the videos. And also if the emotions have unreasonably or very anonymous compared to the normal videos, then they will also be flagged. So lastly, we developed a visual analytics system called Anchorage. So we combined both data sources to help them conduct satisfaction analysis. So our design, because customer service agents will have a various education background, so we use minimal design effort to reduce the learning curve of the visualization to these agents. So simple bar charts is here to showcase the event structure. If the events have less dark colors, then it will be more normal or better, and the more darker colors will attract more attention, so that it kind of remind the visualization readers that they are anonymous. And for the boy charts, which is our main visualization design, we utilize this scatter plot based design to help understanding the multimodal data. With the vertical dimension, we have the satisfaction score for the emotions, and for the horizontal dimension, we have the event score. So to the right part, using the quadrant idea, we can see that if all the dots which the green part represent the facial expression and the red dots represent the acoustic emotion. Then if all the dots are refined to one area, then it will mean that they belongs to this quadrant. So in this case, this will be super satisfied, and this will be satisfied, although some of the procedure are quite slow. And these are the unsatisfied case. And we also utilize this design pattern to the next part of the visualization system, such that the people do not need to learn new visual encodings across the different views in a dashboard. So we evaluated Anchorage based on the ablated baseline system. We removed all the boy chart and also the VIS metaphor. We only present the computer-assisted features in the baseline. We invited 24 domain experts for the between user study. And so the user using our system, using Anchorage, can complete the task 20% faster. In fact, if you see from this graph, except for the first task, all the other tasks have, on average, a lower completion time. So that it means that maybe Anchorage is harder to learn, but once you learn it, you can perform much better than the baseline. And notice that this is a between study, so that the people who use Anchorage has not used baseline or vice versa. So this comparison is very rigorous and legitimate. And also Anchorage can, but if the people annotate faster, it doesn't mean that they do it randomly. We can see that except for normal and satisfied cases where the score is different for the satisfaction score. Otherwise, all the other annotation are almost the same for both systems, meaning that even though we do it faster, we do not compromise the precision accuracy. And lastly, the qualitative feedback is almost the same for the two systems, but we can see that our system is rated less overwhelming. So it's suggested that if we can have a metaphoric design and also a good guidance for introducing the visualization, it might help them to understand and have less overwhelmingness. So lastly, we wanted to show that using improvised data set should be a good test case for fast system, because visualization is for ill-defined problems, and we have our carefully designed cases can be the solution to clarify the problems. And also using improvised data set requires us to include the data novices or domain experts to collect the data and highlight the desired patterns for us. It is good for design study. And second, for video analytics, we should incorporate more event context into it, as a temporal magnifier. So we can collecting more granular data will create presentation challenges, which our visualization has helped a lot. And the magnifier will also help us to understand the procedural and behavior and context of the events in the videos. With large language models, right now we can do it even without the service record, and we can do it just by the conversation itself. And lastly, the metaphoric visualization design has helped multimodal features, because we can use the different priorities, such as in our case, the event is more important than the emotions. So we give it an separated dimension for the quadrants. And also adopting similar design principles will reduces the learning curve. And this is the end of our presentation. Thank you. And if you want more information, please read the paper.